We are recording now. All right, so quick review about what we saw the last class, right? What we saw the last class was how to convert from polar to rectangular coordinates, right? Here is a quick example. This is the point. We just need to use the formula, the two formulas to replace the points, to replace the information, right? So this is the r, this is the theta, here are the formulas. Replace these, put it in a calculator, good to go. We have seen this 3 times already, so I'm just jumping really fast. And precisely the last class, we saw how to change from rectangular to polar. So coming back, right? And we did these exercises. They were pretty simple. This one, remember this exercise? How would you find this coordinate in the polar plane, in the polar coordinate? How would you find these coordinates? Does anybody knows or not? How much is r? How much is theta here? We did it the last class, so all you have to do is look in your notebook. Or just redo it again. Anybody?
90 degrees.
90 degrees is theta. Beautiful. Yes. So we have a theta of 90 degrees. Let me record this. Let me write this in here. So we have a 90 degrees. That is our theta. Right here. This angle. That's 90 degrees, right? That is the easiest part. So we have our theta. But we also need the r and we need the theta, right? We have the theta. How much is the r, the radius? How much is that? Anybody?
3.
Beautiful. I don't know who did it, but yes, you're correct. The radius is this line, right? So the measurement of that line, which is 3. Because we can count 1, 2, and 3, right? Beautiful, beautiful stuff. So we have r3 and theta 90 degrees. In other words, the polar coordinates for this same point are 3, 90 degrees. Don't forget about the little dot for degrees. Cool. We saw that the last class. Today, we're going to learn here, by the way, here is how you do it with a little bit more organization, right? This is the amount of r, and we know r equals 3. Theta, this is the angle, so 90 degrees. Theta. So here are the new coordinates, 3, 90 degrees. You can write this theta in degrees or in radians. I choose to write it in degrees because I'm more familiar working with degrees. But if you want to do it in radians, just change this to radians. Okay, you're good. All right. But what about this? This is how to convert rectangular to polar when the points are on the axis. So we saw the point here, we saw it with the point here, with the point there, and with the point down there. But what about when the point is not in an axis? This is the new stuff today, guys. This is the new stuff today, right? Write down notes, ask questions, and all of the good stuff. And again, turn the camera on. Richie, Luz, Luisa, Juan Diego Rojas, Juan David Ferrand, Maria Paz, Salome, Juan Pablo Pardo. We have a lot of people who could have the camera on because they usually do, but decide not to have it on now. Turn your cameras on, please. Yes. Yes.
Y yo no puedo prender la cámara porque es que a mi mamá se le dañó el computador hoy y ella tiene que bueno, recibir consultas por celular. Entonces tiene que llenar las clínicas y esa vaina. Y pues ella necesita mi computador porque el de ella se le dañó.
Ok.
Entonces, listo,
Okay.
pues. Gracias.
Okay, cool, okay. All right, let's continue. So this is how we're going to take, we're going to approach these exercises. Sophie Vargas says, profe, que María Paz tiene problemas con el internet. Okay, thank you, Sophie. Thank you. All right. The first thing we do, usually, and by usually I mean always, we are going to plot the point here. If we plot 2 comma negative 2, this is the point. Remember, this is in rectangular coordinates. So we just count in x and then we just count on y. This is the point 2 comma negative 2. That's it. Right? So far, so good, right? But now, all we need to do now is to find the r and the theta. Here is where things get a little bit more exciting. Look at this. We are going to determine the distance r from the origin to the point. And this is the formula we are going to use. This is a new formula. Maybe you guys have seen this formula in the past in some other subjects. Maybe in physics or something like that. This is the distance formula. In this formula, all we have to do is replace the values of x and y, these two values, the coordinates, x and y. If we replace the values, we are going to get the distance of r, our radius. Take a look at this. This is our radius, right? Remember, the radius is always from 0, from the center, from the origin, from 0 to our point. That is the line radius, and that is the distance we are looking for. To find that distance, we're just going to take the formula. Again, write down this formula, guys. You are going to do exercises today. We are going to take this little formula. This one is the one for distance. If you are interested in knowing why this formula works, I am going to be more than happy to explain it to you in a tutoring, right? You ask for a tutoring and I told you, I'll show you. We will build this formula together. And you will see this formula is pretty simple, to be honest. All right. From here, replacing the values of x and y. Look, in our coordinates, the x value is 2. Look at that. It's right there, right? Pipe. Cool, brother. Cool. So that is the value, right? 2. We put it right here. X squared. So 2 squared. Right? The value of y is negative 2. All right. So we put negative 2. Remember, because I know you guys are going to change. I'm going to replace this in the calculator. I know that. It is okay to do it. But remember that when you replace negatives, you need to write down parentheses. Otherwise, you're going to have mistakes. So here, we have negative 2 inside parentheses and then the exponent. All right, guys? From here, simply solve this in the calculator and we are going to have 2 square root of 2. Now, we can simplify this a little bit more. 2 square root of 2. We can simplify this more. How? By doing an approximation. How much is this in a calculator, guys? Can anybody tell me? Round it to 1 decimal number, please. Round it to 1 decimal number. Nobody else?
2.8, profe. 2.8.
2.8. All right, cool. So this is the number, right? Right here. This is the number. Square root of 8, if we simplify it, is 2 square root of 2. You know how to simplify this thing, right? If I ask you to do it without a calculator, maybe if we come back to the school, which I don't think so, but maybe, you guys should know how to do this without using calculator, right? But if you are using a calculator, you can just round the number, and the solution will be 2 square root of 2. This is how we put it. New. Here. So this is, let me do it with blue. This is around 2.8, right? No?
Yes, mister.
Thank you. All right, so we have our R, and remember, we're looking for R comma theta. This is what we're looking for. The end result of this exercise is exactly this thing over here. This is the end result. This is what we want to find. And so far, we just found the first part. We know R. So we have 2.8, comma something, comma, I don't know, comma something, comma the angle. The angle. So that is exactly what we have to find. The angle right now. Let me do it with red. this little angle over here. This angle is the one we are going to find, that one, the theta. All right? How are you doing so far? Did you guys get the information of this? The first part, did you get it or not? All right, I see a lot of you saying yes with the camera. All right, cool. All right, cool. So far, it's not that hard, right? Just correct use of calculator. A little bit of water. All right, let's continue. But now, we are going to determine theta, right? The angle. This is our theta right there. Now, you can calculate it downwards or upwards, whatever you choose. Just remember to take into account the sign. If you calculate it downwards, so clockwise, like this, then the angle will be negative, right? But if you calculate it upwards, so counterclockwise, then the angle will be positive. Just choose your weapon, just whatever you want right there. All right, look at this. We are going to find theta by recalling that tangent of theta equals y over x. This is the tangent of theta, right? Take a look at these guys. Tangent of theta. We know by using SOHCAHTOA, remember that? SOHCAHTOA, right? Tangent was opposite over adjacent. Let me do it. Let me write this right here. Yeah. We know that tangent, by using SOHCAHTOA, was opposite over adjacent, right? This is why we have SOHCAHTOA, right? The TOA part. So if we replace in this triangle, we are going to have this information. Look, this is the theta. So the opposite is this side, which is the value of y. And the adjacent is this side, which is the value of x. Again, let me write this. Let me do it here. In this triangle, oof, that was awful, sorry. Again. In this triangle there. In this triangle there and there. In that triangle, this is a right angle, right? This is the angle theta, right? The opposite is this one. The adjacent is this one right here. Right? And this opposite is the y. Because remember, this little line over here, this little line, this one, is the value of y. Is this one right here, is the value of y. And this adjacent is the value of x. Which is why we're saying tangent of theta equals opposite over adjacent, so y over x. Which is what we have right here. Tangent of theta equals y over x. Cool? This is what we are going to use. But we don't want the tangent of theta. We just want the theta alone. That is what we want. We only want the theta. So we are going to isolate it. And we isolate by finding the inverse tangent. The inverse tangent. It is right here. Let me try to fix this. I don't know if I can. A little bit wider. There. Let me see if I can. Let me see if I fix this or not. Maybe you guys can see it better. R, and then theta. There you go. This is the formula now. The one in red. Go ahead and write it down, please. Theta is going to be the tangent inverse. This is how you read this stuff, guys. This is how you read it. The inverse tangent of y over x. You can also read it as theta is the tangent to the -1 of y over x. Or you can also read it as tangent is the arc. I'm sorry. Theta is the arc tangent of y over x. En españolito se lee así. Theta es la tangente inversa de y sobre x. Theta es la tangente a la -1 de y sobre x. O la última. Theta es el arco tangente de y sobre x. Eso de arco tangente es muy, muy, muy usado aquí en Colombia. Si ustedes presentan su saber 9 y les preguntan algo de tangentes, de trigonometría, esa palabra arco aparecerá mucho. El arco solo significa poner este negativo 1 encima. How did you find these values in the calculator? Let me see if I have a calculator here and I can show you. La-da-da. La-da-da-da-da. La-da-da. La-da-da-da-da. There. All right, take a look at these guys. This is my calculator. Right? So if, I don't know if you can see it or not, but tangent to the negative 1, it is right on top of the tangent key. Can you see it? Locate the tangent key, please. Right on top of that one is the one in blue. Look at that. Tangent to the negative 1. It is right there. This is the inverse tangent. It is right there. Okay? That is the one we are going to use. How are we going to use it? Pretty simple. We are just going to replace the values. So theta, the value that we're looking for, remember, we are determining theta. Theta equals tangent to the negative 1, right? This is tangent. If we replace the values here in y and x, these are the values of y, negative 2, and x, 2. We replace this in the calculator. It should give us negative 45. Let's see. Okay, so second quit. Beautiful. I have the calculator here, right? So all I do is second tangent to have the tangent to the negative 1. Then write down the information, negative 2 over, so divided by 2. Close down the parentheses and press enter. Negative 45. There you go. Parrado, you are correct, brother. It is just that. It is just that, guys. Changing from rectangular to polar is just correct use of calculator. That is it. That is it. All right, let's see how you write this information. Negative 45, right? Negative 45. Negative 45. How did you write this information as an answer? Here, right there. That is the answer in red. Since we are looking for coordinates, we need to write parentheses, number, comma, number, parentheses. Again, don't write r equals something, theta equals something. That is half of the answer. That is the process. But you need to remember how to write down a correct answer. And the answer is written in coordinates. So parentheses, number, comma, number, parentheses. By the way, if you wanted, you can leave this number like this, 2 square root of 2. But if you don't, you can just put it in the decimal form, 2.8. That is okay as well. That is okay as well, 2.8.
Okay, y lo podemos aproximar.
Sure, 2.8. Yeah, what I just said, yes. Let me do it again. There. If you want to, you can write this with an approximation. Approximated to 2.8, right? Comma, negative 45 degrees. This is correct. This is also correct. Both of them are correct. All right? We get it, guys? Did we get it or not? Thank you, Sarita. Salud. Nobody else got it? Say something in the chat or show me your face in the camera. I don't know, something.
Yes, mister.
Thank you. Thank you.
Yes,
Appreciate it.
mister.
Thank you. You need to let me know, guys. Otherwise, I'm not going to know if I am teaching correctly or not, if I should redo this again or not. All right. You need to answer my questions, please. Beautiful. All right. That is that. Let's jump into another example. Let's take a look at this one. This is example number 2. Let's change these rectangular coordinates to polar. Now, I know here there is a square root of 3. right? And that is an awful number for some of you. I know, I understand that. Some of you might see this number and say, no, no. Ah! I know that. But it is okay. If you want to, you can just round this number to a decimal. Things will work just fine. Things will work just fine. Right? Don't get scared about this. It's just a regular number. All right, this is how we do it. Step number 1, we are going to plot this point. Always, please, plot the point. I'm going to show you why it is so important to plot the point in this example. If we plot the point, we know that here, this is the position -1 comma negative square root of 3 here. This right there. I decided to do it with this drawing because it doesn't really matter where the 1 is. Here should be the -1. Let me show it to you. If this is the point, then here is -1, right? Because this is the value of x. Right? And here, right there, is the point negative square root of 3. Right? That is the point. It makes sense. Look, it's negative and negative. So it makes sense that it was located in quadrant number 3. It makes sense. Right? Right there. Cool. That is the point. Now, from here, let's try to find r and the whole theta. Let's do that thing. Pretty simple. Remember the formula for r? We just do the same process again. That is what we do. We just do the same process again. We replace using the formula for r and the information in the coordinates. So x is -1, so we put it right here, -1. Since it is a negative number, we put it in parentheses. Remember, negative numbers, we put it in parentheses in the calculator, -1. Plus y to the second power, right? Right to the second. So y is negative square root of 2. Don't forget about the signs. Negative square root of 2. Again, if you hate this root, it's okay, just change it to a decimal. Things will work out just fine. From here, put this in a calculator and let's see who is working with me and who is not. Tell me, please, in the chat, how much is that? You can round it to a decimal if you want to, although you don't have to, right? Because the solution is integer, right? The solution is an integer number. Anybody? In the chat, please. All right, 3 people, 4 people. All right, beautiful. Parrado? Are you not doing it? Okay, cool. Okay, all right. Thank you to all the people who are working. Thank you. Remember, in math, you don't learn by just looking at the screen. You learn by doing. So congratulations to all of you who are actually learning in math because you are doing. Yes, the solution is 2. Pretty simple. We just put this in the calculator and we get the result square root of 4. But if we press enter again, that is 2. So we know the value of r. R equals 2. We write it down in a corner or something. Now we continue from there. From having the value of r, we continue with theta. We're going to determine this whole theta. This is what we're going to do, all right? Let's see. I don't know. I'm not asking you to find it right now. I'm not asking you to find it. I'm asking you to approximate. Guys, by guessing, guess, please guess. Make an assumption, all right? Tell me in the chat. How much do you feel? Don't calculate it. Feel. How much do you feel? How much do you think theta is going to be? How much? In the chat, please. Look at the drawing and tell me, I don't know, teacher, but I think theta is about something. I don't know, it's bigger than whatever. It's around this and that. Make an assumption, guys. Make an assumption, please. All right, let's see. Let's see some solutions, some possible answers. All right. I only have 4 answers, guys. Everybody else, please make an assumption. Don't just copy what everybody else is saying, right? Make your assumption. I'm not gonna read your answers. I'm sorry. I am gonna read your answers, but I'm not gonna read your names. So it doesn't really matter, all right? Go ahead and give it a try. Think about the angle theta and tell me, how much do you think that is the measurement? All right, we have 17 answers now. All right. So the answers varies from 225. So people are saying this angle is 225, 300, 350, 245, 280. So what? Bigger than 200, right? Most people are saying bigger than 200, right? 250, 250, 225. We even have some negative numbers, right? People are saying we also could have negative numbers because we can measure the angle like this, right? We can measure the angle like this. If we measure the angle like this will be a negative number, but it will be bigger than 90, right? It'll be what? 120, negative 120 maybe? It could be, right? Negative 120 or something like that, right? Negative 200 will be something around here, right? All right, so let's take a look. Now that everybody has an assumption in mind, let's use the formula to see if we get it or not. Now let's use the formula. So here, remember, this is the formula. Theta, the angle, can be found by using tangent to the -1 of y over x. If we put this information in the calculator, remember, negative square root of 3 over -1, right? Y over x. If we put this in the calculator, this is the result. Theta equals 60, right? Is anybody doing it?
Yo lo había hecho en mi calculadora y tenía 60.
Uh-huh. So
Mira.
what happened there? We looked at the drawing and we assumed it was bigger than 200, 245, 220, 250, 280. We had a big number. It makes sense. The angle is big. But the calculator is telling us the angle is 60. 60 means it's even lower than this. 60 means the angle is around here. This is 60. It doesn't make sense. It doesn't make sense, guys. It doesn't make sense. Paso un momentico al español. Cuando trabajamos pasar de rectangulares a polares, hay que hacerle algo a la fórmula. Hay que hacerle una corrección a la fórmula. La fórmula es buena para algunos casos, no para todos. Les voy a mostrar cómo se hace esto, ¿listo? Hay que hacerle una corrección, ¿listo? Sarita, R is negative? No. If you look at R as negative, yes. You could count as R as negative, and that would be correct. So you could have -2,60, and that would be correct, Sarita. Yes, that would be correct, right? All right, this is how you make the correction. Take a look at this. Theta, 60. What? What is that? No. This is clearly a mistake, right? The angle is not 60. We saw it already. Since the point lies in quadrant 3, there, look at that. Remember, I show it here. This is quadrant 3, right? Quadrant 3. Right? We need to add 180. This is the correction. This is what we have to add. 180 to obtain the angle in quadrant 3. So look at now at the formula. The formula is the usual formula that we had plus the correction, 180. So replace the values, 180 plus 60, and the real angle was 240. Congratulations to the people in the chat. Congratulations to the people in the chat who get 240 precisely. All right, pretty good, pretty good. I think one person got it. One person, yes, congratulations. 240 precisely, right? Again, guys, remember, we need to make a correction because the point is located in quadrant 3. So there is an importance behind plotting the points. We need to plot the points before doing the formulas. If you just jump into the formulas, you are going to have mistakes because you're not going to know if you have to make a correction or not. You plot the point. Guys, plot the point first. Always, please. All right, let's continue. These are the solutions, right? We have r equals 2, theta equals 240. So these are the coordinates, 2, 240, right? Now, we have, I know. Let me do it here. Those are the coordinates here. 2, 240 degrees. Right? Now, Sarah Manuela, just realized that you could also do something. Look, the other angle that the calculator gave us was this one, right? 60 degrees. Well, she recognized that this meant the value r is negative right here because this is the r. So if we look at it negatively, the value r is negative r. So another possibility for this angle will be, let me write this again. Another possibility for this angle will be -2, negative the r, 60 degrees. That is another possibility. Sarita is correct. This is right. This is right. You do whatever you choose. I feel like this one is easier, but man, if you want to do the one on top, that's okay as well. All right. Here are the formulas per quadrant. Here are the corrections you need to do according to each individual quadrant. So here, for quadrant 1, if the point is in quadrant 1, you don't need to do no correction. Look, it's the regular formula. We have the r and the theta. That's it. R and theta. But if the point is in quadrant 2, we need to make one correction. We have to make one correction. R is the usual point. R is the usual formula. But theta, we need to add 180. For theta, we do need to add 180.
Profe,
Right?
pero ¿cuál es la lógica de añadir 180? sea,
¿Cómo te lo explico? A ver, me echa a ver si de pronto es muy avanzada esta explicación. Ponle cuidado. Si yo aquí dibujo tangente de teta, esa es la figura de tangente de teta. ¿Sí estás viendo?
Sí, señor.
Así queda tangente de teta, ¿sí? Tangente de teta tiene unos huecos, papá, tiene unos huecos. Esto no es una figura continua. Esto tiene unos huequitos, mira, unas asímptotas se llama. Mira, esta línea, si yo me expando para afuera, si yo me expando, esta línea sigue creciendo. Y mira cómo la línea verde no se acerca aquí al 2. No se acerca, mira. Bueno, pues es como por aquí, como el 3 algo, mira. Sigue subiendo, pero no pasa. Eso es una asímptota, eso es un hueco. Eso es exactamente en pi medios, perdón. Aquí, por aquí en pi medios. 1 punto alguito, 1.5, 1.6, 1 punto alguna cosa. Aquí está la asímptota. Teta nunca va a tocar eso. Entonces, cuando hablamos de la inversa, corremos esta. Arco tangente de teta. ¿Sí? Arco tangente a la menos 1. Cuando hablamos de la inversa, también hay unos valores que nunca va a tocar. Pi medios y más de pi medios. Pi medios era 90 grados. ¿Sí o no? En radianes. ¿Sí me está siguiendo o no?
Sí, señor.
Ok. Entonces mira que esta fórmula nunca va a calcular tangente a la menos 1, arco tangente. Nunca va a calcular valores mayores de pi medios. Venga, pongamos aquí pi medios. Ay, no lo puso. Borremos esto. Ahí está. Mira, esta es la asíntota, la de rojo. Mira, la azulito se acerca, pero en realidad como que se combina, pero nunca atraviesa la roja, nunca. Entonces, si elegimos un ángulo mayor a pi medios, mayor a 90, la fórmula no nos funciona. La fórmula se destruye. Esa es la razón, porque por aquí no pasa. No hay un valor para el cual la fórmula sea mayor de pi medios. No hay. Lo mismo para negativo pi medios. Pongámoslo aquí, mira. Y igual negativo pi medios. Ahí está. Esta es la otra asíntota, mira. Abajito nunca va, la fórmula, la función nunca va a tomar un valor menor que pi medios. O sea, un ángulo menor que 90 tampoco funciona. Perdón, menor que negativo 90, quise decir. Menor que negativo 90. Nunca va a funcionar tampoco. Entonces, por eso le hacemos una corrección, porque nos damos cuenta que si ponemos un ángulo mayor, pues la fórmula no nos funciona. Se totea la matemática. No ve que no hay un valor. Entonces, hacemos la corrección por eso, papá. ¿Sí me hago entender?
Sí, más o menos. Ahí algo entendí.
Ok, esto para
Vale.
la gente que le guste la matemática, esto es lo que verán en análisis. Esta es la diferencia entre análisis y aplicaciones. Análisis es, vamos a mirar el por qué. Entonces, cuando Richie pregunta, profe, ¿y por qué demonios tengo que sumarle 180? ¿Cuál es la razón? En análisis van a mirar la razón. En aplicaciones solo uno se queda con que hay que sumarle 180 y ya está. La diferencia entre las materias, ¿listo? Para que estudien, no, para que decidan bien su elección a futuro. All right, let's continue with this. That was a little bit of a break, a little bit of a parenthesis, right, to explain. Let's continue with this, right? So here, quadrant 1, no correction. Quadrant 2, a correction of 180 degrees, right? 100 plus tangent. For quadrant 3, so a point around here. Quadrant 1, quadrant 2, quadrant 3. A point in this quadrant. The usual formula for radians, the usual formula, right? But a correction in tangent. Again, 180 plus the angle. We are going to add 180. If we are doing this using radians, then we don't add 180. We add pi. Because pi is 180 degrees, right? All right. And last but not least, what happens when the formula is in quadrant number 4? Right? The point is in quadrant number 4. This is the usual formula for the radius, right? For the distance. And this is the formula for tangent. Look at that. No correction. So we only make a correction in these two. Quadrant 2 and quadrant 3. And what is the correction, teacher? Add 180. That's it. Whatever the result is, add 180. That's it. That is it, guys. Right? Look, if you like to take screenshots, go ahead and take a screenshot of this right now because there are a lot of formulas. Maybe these formulas can help you, right?
Wait a minute, mister.
Sure. Can I continue now? What about now? Can I continue now?
Mister?
Yes. Carlos?
Also, if we want to calculate the R, we can only, for example, in the last exercise or example, we can only measure the distance from 0 to the point that we plot in the graphic, and it will be the same too. So I can calculate the R without using this formula, right?
So you mean measuring with a ruler? With a ruler?
Yes.
All right, there is a problem there, Carlito. There is a problem there. Let me see if I find a ruler, and I'll show the problem in my board. Give me just 1 second. I'm gonna go find a ruler. Give me 1 second. Give me 1 second. I'm back. Sorry, guys, to keep you waiting. All right, I was looking for this. I have a ruler. Well, this part is the ruler, right? All right. this is the problem, guys, when we rely on measurements. This is the problem. Take a look at this, guys. Take a look at this. Take a look at my example. So let's say we want to plot that one, right? In the previous example. So we had this. And right? And the point was -1, here is -1, comma, negative, the point was -1, comma, negative square root of 3, right? Can you help me with this value? How much is the square root of 3, guys? How much?
-1 point something. I don't remember. Negative.
Negative 1.7.
Yes.
Negative 1.7. Thank you. All right. So this is the -1, right? This is the -1, right? And negative 1.7 should be here, so around there, right? Negative 1.7. So this is the point, right there, right? Meaning the value R comes from this line, right? Are you guys following? Carlitos, are you following me?
Yes, mister.
Cool, cool. Thank you. Cool. So now let's take our ruler. Now, this is the usual ruler. Look, the usual ruler. That thing has centimeters, millimeters. That is the usual ruler. I'm not using a different ruler here. And if we measure, put it from 0 to the center, right? And I got 7. This is the position I got. I'm going to show it to you here. Here. This is what I got. I don't know if you guys can see it or not. There. Bigger than 6. I got 7 centimeters right there. 7 centimeters. To me, R equals 7. Because I just used a ruler. Why is this wrong? Can anybody say it?
Because of the proportions.
Yes, Sarita. In my drawing, I don't have every number, every unit at 1 centimeter away from the other. No, I don't have that. In my drawing, the number 1 is at 3 centimeters. It's at 3. So the proportions change. The proportions change. So you can use this to measure, just not always. In fact, most of the times, you can't. Most of the times, using this will give you mistakes. Most of the times. This is a good tool. A good tool for beginners. For when we are in 6th grade, 7th grade, and we want to practice. But now that we are in 9th grade, we are no longer beginners. We're not noobs. We're a little bit better, right? We're not level 1, level 2, we're on level 50. We are better. We are better. So we don't use this. Use the calculator. And when you guys are expert, when you guys get to the university, if you study math, of course, you're not even going to use the calculator. I'll show you if you guys want to study that. Sometimes, maybe, I can show you how to calculate this measure without even using calculator. Without even using the calculator. Those are the levels, right? So if you're noob, you use this. If you're no longer so noob, so not beginner, you just use the calculator. And if you are an expert, you don't even use the calculator, just your mind. All right, that is the reason, Carlitos. Hopefully that helped you. Is that okay, Carlitos? Yes or no?
Yes, mister.
Cool, Carlitos. Cool.
Yes.
Cool. All right. So let's get back to the presentation. From here, let's jump into some exercises, guys. It is time to practice. We have 40 minutes to do these exercises from 55 to 66 of the page 726. 726. Here, let me do this bigger. Okay, there. So 55 here, from 55 to 66. These are the exercises we need to do, these ones. 12 exercises, all right? I want you to find the polar coordinates. And I am giving you the rectangular coordinates. Every single one of these points is a rectangular coordinate. Find the polar ones. That's it, guys. Remember to always plot the points first so that you know in what quadrant that point is located. You need to know what quadrant because you want to know if you are going to add 180 or not. That is the reason, right? That is the reason. All right. I'm going to stop the recording now. Remember, if you have any doubts, you can always ask me, guys. Let's get to work. Thank you.